Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Tasya Wulandari and I am from 5B class. In this great opportunity, I would like to tell you about the interpretation of data. But I want to focusing in telling you far about how to get to the methods, benefits, and problems of the interpretation of data. First, what is the data interpretation itself? Data interpretation refers to the implementation of processes through which data is reviewed for the purpose of arriving at an informed conclusion. The interpretation of data assigns a meaning to the information analyzed and determines its significance and implications. The importance of data interpretation is evident, and this is why it needs to be done properly. Data is very likely to arrive from multiple sources and has a tendency to enter the analysis process with haphazard ordering. Data analysis tends to be extremely subjective. It is to say, the nature and goal of the interpretation will vary from business to business, likely correlating to the type of data being analyzed. While there are several different types of processes that are implemented based on individual data nature, the two broadest and most common categories are quantitative data analysis and qualitative analysis. Go on to the next slide. Yet, before any serious data interpretation inquiry can be begin, it should be understood that visual presentations of data findings are irrelevant unless a sound decision is made regarding scales of measurement. Before any serious data analysis can begin, the scale of measurement must be decided for the data, as this will have a long-term impact on data interpretation. The varying scales include: the first is nominal scale, or non-numeric categories that cannot be ranked or compared quantitatively, or variables are exclusive and exhaustive. The next is ordinal scale, exclusive categories that are exclusive and exhaustive but with a logical order. Qualitative rating and agreement ratings are examples of ordinal scales. Example: good, very good, and etc. The interval measurement scale, where data is grouped into categories with orderly and equal distance between the categories. There is always an arbitrary 0 point. The next is ratio, that contains features of all the three. Go on to the next slide is how to interpret the data itself. When interpreting the data, an analyst must try to discern the differences between the correlation, causation, and coincidences, as well as many other, but also has to consider all the factors involved that may have led to a result. There are various data interpretation methods one can use. The interpretation of data is designed to help people make sense of numerical data that has been collected, analyzed, and presented. Having a baseline method or methods for interpretation data will provide your analyst teams a structure and consistent foundation. Indeed, if several departments have different approaches to interpret the same data, while sharing is the same goals, same mismatched objective can result. This disparate method will lead to duplicated effort, inconsistent solution, wasted energy, and invaluable time and money. In this part, go on to the next slide. We will look at the two main methods of interpretation of the data, with a qualitative and a quantitative analysis. First is qualitative data interpretation. It can be summed up in one word, or categorical. With qualitative analysis, data is not described through numerical values or patterns, but through the use of descriptive context. Typically, narrative data is gathered by employing a wide variety of person-to-person techniques. The techniques include first observations detailing behavioral patterns that occur within an observation group. These patterns could be the amount of time spent in activity, the type of material, the type of activity and the method of communication employed. The next is document, much like how patterns of behavior can be observed. Different types of documentation researches can be coded and divided based on the type of material they contain. The next is interviews, one of the best collection methods for narrative data. Inquiry responses can be grouped by the theme, topic, or category. The interview approach allows for highly focused data segmentation. Go on to the next slide. A key difference between qualitative and quantitative analysis is clearly noticeable in the interpretation stage. Qualitative data, as it is while widely open to interpretation, must be coded so as to facilitate the grouping and labeling of data into identifiable themes. As person-to-person data collection techniques can often result in disputes pertaining to proper analysis, qualitative data analysis is often summarized through three basic principles: notice things, collect things, and think about things itself. Go on to the next slide is about the second. It is quantitative data interpretation. If quantitative data interpretation could be summed up in one word, and it really can't, that word would be numerical. There are few certainties when it comes to data analysis, but you can be sure that if the researchers you are engaging in has no number involved, it is not quantitative research. Quantitative analysis refers to a set of processes by which numerical data is analyzed. More often than not, it involves the use of statistical modeling such as standard deviation, mean and median. Okay, let's quickly review the most common statistical terms. The first is mean. A mean represents a numerical average for a set of responses. When dealing with a data set or multiple data sets, a mean will represent a central value of a specific set of the number. It is the sum of the values divided by the number of values within the data set. Other terms that can be used to describe the concept are arithmetic mean, average, and mathematical expectation. The next is standard deviation. It is another statistical term commonly appearing in quantitative data analysis. Standard deviation reveals the distribution of the responses around the mean. It describes the degree of consistency within the responses. Together with the mean, it provides insight into the data sets. The next is frequency distribution. This is a measurement gauging the rate of the responses appearance within the data set. When using a survey, for example, frequency distribution has the capability of determining the number of times a specific ordinal scale response appears. For example, agree, strongly agree, and disagree, etc. Frequency distribution is extremely keen in determining the degree of consensus among the data points. Okay, let's go on to the next slide. Typically, quantitative data is measured by visually presenting correlation tests between the two or more variables of significance. Different processes can be used together or separately, and comparisons can be made to ultimately arrive at a conclusion. Other signature interpretation processes of qualitative data include: first is regression analysis, cohort analysis, predictive and prospective analysis. Go on to the next slide. Why data interpretation is important? The purpose of collection and interpretation is to acquire useful and usable information and to make the most informed decision possible. From business to newlyweds researching their first home, data collection and interpretation provides limitless benefits for a wide range of institutions and individuals. Data analysis and interpretation, regardless of method and qualitative or quantitative status, may include the following characteristic. The first is data identification and explanation, comparing and contrasting of the data, and identification. The next is identification of data outliers and future predictions, of course. Data analysis and interpretation, in the end, will help improve the processes and identify problems. It is difficult to grow and make dependently improvements without, at the very least, minimal data collection and interpretation. What is the key word? Dependently. Vague ideas regarding performance enhancement exist within all institutions and industries. Yet, with the proper research and analysis, an idea is likely to remain in a stagnant state forever. For example, is minimal growth. Go on to the next slide. So what are the view of the business benefits of digital age data analysis and interpretation? Okay, let's take an example. The first is let's take a look. The first is informed decision making. A decision is only as good as the knowledge that formed it. Informed data decision making has the potential to industry leaders apart from the rest of the market peg. The next is if the institution only follow the simple order, one that we should all be familiar with from grade school science fairs, then they will be able to solve issues as they emerge in real time. The next is anticipating needs with trends identification. That data insights provide knowledge, and knowledge is power, so that the insight obtained from market and customer data analysis have the ability to set trends for peers within similar market segments. A perfect example of how data analysis can impact trend prediction can be evidenced in the music identification application. When industry trends are identified, they can serve a greater industry purpose. Go on to the next slide is cost efficiency. Proper implementation of data analysis processes can provide business with profound cost advantages within their industry. Recent data study performed by Deloitte vividly demonstrates this in finding that data analysis is driven by efficient cost reduction. Go on to the next example. The next example is the clear forensic. Companies that collect and analyze their data gain better knowledge about themselves, their processes and performance. They can identify performance challenges when they arise and take action to overcome them. Data interpretation through visual representation lets them process their findings faster. Go on to the next slide. It is about the data interpretation problems. The oft-repeated mantra of those fear data advancements in digital age is big data equals big trouble. While that statement is not accurate, it is safe to say that certain data interpretation problems or pitfalls exist and can occur when analyzing data, especially at the speed of thought. Let's identify 3 of the most common data misinterpretation risks and shed some light on how they can be avoided. Go on to the next slide. Is about the first is correlation mistaking for causation. Our first misinterpretation of data refers to the tendency of data analysts to mix the cause of phenomenon with correlation. It is the assumption that because two actions occur together, one cause to another, it is not accurate, as actions can occur together absent a cause and effect relation. The digital age example, assuming that increased revenue is the result of increased social media. Remedy is attempt to eliminate the variable you believe to be causing the phenomenon. Go on to the next slide. Is confirmation bias. Our second data interpretation problem occurs when we have a theory or hypothesis in mind, but are intent on only discovering data patterns that provide support while rejecting those that do not. The digital age example is our boss asked to analyze the process of recent multi-platform social media marketing campaign. While analyzing the potential data variables from the campaign, you see that the share rate for Facebook posts were great, while the share rate for the Twitters were not. Using only Facebook posts to prove your hypothesis that campaign was successful would be a perfect manifestation of confirmation bias. And the remedy is, as this pitfall is often based on subjective desires, one remedy would be to analyze data with a team of objective individuals. If it is not possible, another solution is to resist to argue to make a conclusion before the data exploration has been completed. Remember to always try to disprove a hypothesis, not prove it. Go on to the next slide. It's about the irrelevant data. Pitfall is especially important in the digital age, as large data is no longer centrally stored, and as it continues to be analyzed at the speed of thought, it is inevitable that analysts will focus on data that is irrelevant to the problem they are trying to correct. For example, a digital age example is in attempting to gauge the success of an email lead generation campaign. So the remedy is proactively and clearly frame any data analysis variables. And prior to engaging in data review. Go on to the next slide. It is about the interpretation of data. The use of dashboard bridging the gap, as we have seen, quantitative and qualitative methods are distinct types of data analysis. Both offer a varying degree of return on investment regarding data investigation, testing, and decision making. Because of their differences, it is important to understand how the dashboard can be implemented to bridge information gap. How are digital data dashboard solutions playing a key role in merging the data disconnect? Here is the ways. The first is connecting and blending the data. A business continue to globalize so that data dashboard decentralized data without compromising on the necessary speed of thought while blending both quantitative and qualitative data. Whether you want to measure customer trends or organizational performance, you now have the capability to do both without the need for a singular selection. The next is mobile data. Related to the notion of connected and blending data is that of the mobile data, so that employees are spending less time at their desks and simultaneously increasing production. So that mobile analysis applications seamlessly integrate with everyday business tools. In turn, both quantitative and qualitative data are now available on demand where they are needed, when they are needed, and how they are needed. Go on, visualization, data dashboard. Data dashboard are merging the data gap between qualitative and quantitative methods through the science of visualization. All of these visual characteristics make for an easy transition among the data methods. You only need to find the right types of data visualization to tell your data story the best way possible. To give you and how market research dashboard fulfill, so it brings together both qualitative and quantitative data knowledgeable, analyze and visualize in meaningful way that everyone can understand. This empower any viewer to interpret it. Okay, go on to the next slide. Is data interpretation method summary and list and tips. Data analysis and interpretation are critical to develop sound conclusion and make better informed decisions. As we have seen all along this article, there is an art and science to the interpretation of data. Hereafter is a list summary of how to interpret the data and some tips. The first is collect our data and make it as clean as possible, and then choose the type of the analysis to perform, qualitative or quantitative, and apply the methods respectively to each. And qualitative analysis, observe, document, and interview, notice, collect, and think about things. Quantitative analysis, you lead research with a lot of numerical data to be analyzed through various statistical methods, mean, standard deviation, or frequency distribution, for instance. Go on to the next slide. Is take a step back and think about our data from various perspectives and with it what it means for various participants or actors of the project, and reflect on our thinking and reasoning, and be aware of the many pitfalls data analysis and interpretation carries: correlation versus causation, subjective bias, false information, and incorrect data. So to conclude that the importance of the data interpretation is undeniable. Dashboards not only bridge the information gap between traditional data interpretation method and technology, but they can help remedy and prevent the major pitfalls of interpretation. As a digital age solution, they can be combined the best of the past and the present to allow for informed decision making with maximum data interpretation. I think that's all from me. Thank you for your great attention, and wassalamualaikum warahmatullahi wabarakatuh.